Hello students. In this video, we will be covering Chapter 7 of your textbook, Percent Applications. So the first application that your book discusses is the application of understanding discounts like when you're at a store. So you're given this equation, this markdown equation, which says, okay, if you're in a store and something is marked down by a certain percent, the marked down price, so the price you pay after the markdown, that's equal to the original price minus the markdown percent times the original price. And so this, thinking through it should make some sense. You're just, all right, what's the markdown? You take the original price. And if the markdown percent is 30%, that means you're taking away 30% of the original price, which is exactly what this says. An equivalent way to write this is to, we see the original price showing up here and here. We can factor out the original price, and just one algebra step gets us an equivalent way of writing the same equation. Now, I would say the virtue of writing the equation this first way is that it's the way we think about it. The virtue of writing the equation down the second way is that I find it easier to do calculations with. But that's just, it's a matter of taste. Either one of these is fine. Let us note, though, that this markdown percent here, in both of these cases, you have to write that as a decimal or a fraction. If the markdown is 25%, do not write 25 here. You got to write 0.25. You got to take 0.25 times the original price. If you did like 25 times the original price, then you're subtracting 25 times the original price from the original price. It doesn't make any sense. So it really should be a decimal or a fraction there. Okay, let's do some examples. Here, let's find the markdown price. So let's say we know the original price. The original price for a pair of jeans is $24.99. The store is offering a 30% off sale on the jeans. How much will you pay after the discount? I do not buy expensive jeans, as you can tell. So, all right, well, using, let's say, this original equation, the original price is $24.99, so we'll put that here and here. And the discount is 30% off, so we're going to put 0.3 here. And then we have to calculate the marked down price. So go ahead and pause if you want to try to do this yourself first. Otherwise, we have, using this first equation, this setup. Now, if we use the second equation, okay, the markdown price we still don't know. The original price is $24.99, and then it's 1 minus the markdown percent, which is 0.3. And in either case, when you put this into your calculator, you should get $17.49. That is the price you pay after the 30% discount. All right, let's do another example. Suppose now you see the same jeans for sale for $15.99. How big of a sale is the store offering now? I'll let you pause and try to think through this one, see if you can solve it yourself. Otherwise, so I'm going to use this second equation. Again, I just prefer to use the second equation when doing calculations, but you could do either one. So I know, I'm saying a week later, the marked down price is $15.99. And I want to know what was the markdown percent. Well, okay, the markdown price was $15.99. The original price was still $24.99. And now I've got 1 minus the markdown percent, which is X. That's what I want to solve for. And so, all right, maybe I'll just do the calculations really quick to solve for X. So you divide both sides by $24.99. Whoops, 90, wow, 9. So that cancels that. And so you have 1 minus X equals $15.99 divided by $24.99. So you Maybe add x to both sides. And then, so that brings the x over here. And then you got to move this 1599 over 2499 over there. So you like, I don't know, also minus 1599 over 2499 from both sides. And then you should get x is 1 minus 1599 over 2499. Okay, and plugging that into your calculator, you get x is 0.36 or 36%. And now let's do one more example. All right, now a different brand of jeans, let's say costs $36 after a 10% discount. So what was the original price for this pair of jeans? Again, I encourage you to pause and try to use the formulas to figure this one out. Well, okay, again, we know this $36 is the marked down cost. So the markdown price is 36. And again, I'm using this second equation just because I find it easier to deal with. You want to find the original price. We don't know what that is, so that's our x. And that's times 1 minus the markdown percent. There's 1 minus 0.1 because the markdown percent was 10%. And so this is going to be 0.9, so it's going to be 36 divided by 0.9. So the original price was $40. Now, notice these are basically the only questions I can ask you. Similar to the percent equation, there are only 3 things here. It's the marked down price, the original price, and the markdown percent. Markdown price, original price, the markdown percent. So all I can basically do is give you 2 of these and then ask you to find the one that I didn't give you. And so the only questions I can ask are going to be kind of along these lines. All right. The next application your book discusses is percent change, which is a really handy thing to understand. You see percent changes being discussed, if you read the newspaper or op-ed or something like that, you'll see percent changes given all the time. So it's good to understand where these come from and what it means. So your book gives you this percent change equation. So if you have 2 quantities, we'll call them Q1 and Q2, then the percent change between the quantities is Q2 minus Q1 divided by Q1 times 100. And notice that this times 100, all that's doing is automatically converting the answer to a percent. So what you get at the end has a percent sign on it. I would say the biggest problem students run into is knowing what to use as Q1 and what to use as Q2. So Q1 should be the value that is changing. Like oftentimes percent changes are given over time. It's like, oh, the percent change in, I'm having trouble not thinking of anything related to coronavirus. So like, oh, the percent change in vaccination rates from 1 month to the next. These are things that are changing over time. And so you want to know the percent change. And so your Q1, when you're calculating something that's changing over time, your Q1 should be the first thing. Your original value, that is the thing that is changing. And it's changing to Q2. So this is your new value. So this is your Q1 is your original value, Q2 is the new value, and you calculate the percent change by taking the new value, subtracting the original value, and dividing by the original value. So if there's anything that's going to get messed up here, it's going to be switching around Q1 and Q2. So just, be careful about that. Let's do an example. Okay. Suppose you leave your job in data entry, making $12 an hour, for a job taking customer calls, making $13.50 an hour. By what percent does your hourly wage increase? I encourage you to pause and try this for yourself. Okay, the first thing you should do is figure out what's your Q1 and what is your Q2. Well, the thing that is changing, your original value, is this $12 an hour. That's your original wage. So this should be your Q1, and your Q2 is $13.50. This is your new wage. And so finding the percent change, we just throw these into the equation. Q2 minus Q1 divided by Q1 times 100 gives you, if you put it in your calculator, you should get 12.5%. So you have a 12.5% increase in your wages, changing from a $12 to a $13.50, $13.50 per hour job. Okay, let's do another example. Okay, turns out you hate customer service and decide to return to the data entry job. Now, by what percent does your hourly wage decrease? Again, I can encourage you to pause and try this yourself. Well, okay, now I suppose maybe before even going on, I should say, all right, what is our Q1 and what's our Q2 now? Well, now you're starting at your customer service job that was making $13.50 an hour, and you're going back to your data entry job making $12 an hour. And so your Q1 in this situation is the $13.50 an hour because that's the job you have, and you're changing to data entry. So your Q2 is the $12 an hour. So the setup is 12 minus 13.5 over 13.5 times 100, which is minus 11%. And now, when I've taught this concept in the past, some students are, I guess, worried that the percent change isn't the same because the dollar amount is the same. You're increasing by, in this first scenario, you're increasing from 12 to 13.50. So that's an increase in your wage by $1.50 per hour. In here, you're decreasing from 13.50 to 12, so you're decreasing by $1.50 per hour. But the percent changes are different, even though the dollar per hour change is the same. And that's because in this first scenario, when you're going from $12 an hour to $13.50 an hour, all right, so that $1.50 difference, that's a bigger portion of 12 than it is going from 12 to 13, or going from 13.50 down to 12. All right, now you're losing $1.50 an hour, but that $1.50 now is a smaller portion of 13.5. So that's why these 2% changes are different, even though the dollar amount in change is the same. And it's just because 150 is a bigger part of 12 than it is of 13.5. Okay, the final application we're going to talk about is weighted averages, which I'm going to be the first to admit it's going to be a little bit of a slog. There are a lot of different kind of nuanced questions that can be asked, and there's a lot of calculations that happen. So let's just, bear with this. It builds character, I suppose. And, this is something that if you're a teacher, you're definitely going to have to know how to do. Teachers use this all the time. And as a student, there are natural questions you ask. I mean, questions I get emailed all the time about students' grades. This should empower you to be able to calculate things like your grade in the class at any given time yourself. Okay. So a weighted average is a situation where different categories account for different amounts of the total. And the most common place you see this is going to be in a class. So for example, in this class, we have your grade is based in 5 different categories, and each of these categories accounts for a different percent of the total grade. So your practice problems count for 15% of the total grade, your reflections count for 15% of the total grade, the weekly homework counts for 30%, and each project counts for 20% each. And so let's look at an example where we might use or might be asked to calculate something based on weighted averages. Okay, in this class, in the class we're in right now, suppose that by the end of the term, you have an average score of 90% on the practice problems, an average score of 80% on the reflections, an average score of 82% on the written homework. Okay, and suppose that on the projects, you score 71% on project 1 and 80% on project 2. What's the final grade in this class? Well, to calculate a weighted average, you want to say, all right, well, how much of this 15% of the grade am I getting? How much of this 15% am I getting? How much of the 30% am I getting? How much of the 20% and how much of the 20%? And you kind of add that all up, and that tells you how much of the total. So starting here, say you have an average score of 90% on the practice problems, then we take 90% of that 15%. So converting both of these to decimals, it's 90%, 0.9 times that 15%, 0.15. So by getting 90% on the practice problems, we have 90% of the 15% of the allotted points on that. Next, we have 80% on the reflections. So we're taking 80% of that 15%. I'm going to add it. Next, we have an average score of 82% on the written homework. So we've earned 82% of this 30%. Add that in. 71% on project 1. So we're taking 71% of that 20%. And let's see, 80% on project 2. So we have 80% of that 20%. And that's all. This is accounts for all of the points that we've earned in this class. Add it all together, and it's 0.803. And so we have 0.803, or 80.3% of the total, which, okay, would be a B minus, which would be a little bit of a bummer, I suppose. We all like better grades than that. All right, here's a related question, something I certainly get asked a lot. It's the end of the term. Suppose you've completed every assignment except for the final project, project 2. Often I'll get asked, what's the best grade I can get in the course if I do the best on project 2? What's the best grade I can get? And so to answer that question, you'd use the same technique as the previous problem, except you just assume that for project 2, you're getting 100%. And you say, all right, if you get 100% on project 2, what would your grade be? And then you calculate your grade the same way as before. You have that 90% of 15%, 80% of 15%, 82% of 30%, 71% of 20%. And now we're assuming you have 100% of 20% of that final 20%, which is just, converting 100% to a decimal is just 1. So it's 1 times that 0.20. Add it all up, convert it to a percent, and so I guess if you started out here, the best you could do in the class would be to actually get a B. All right, more related questions. Right, suppose the homework is worth 30% of your grade in this class. It is. Then there are 8 total homework assignments, which I believe is true. What percent of your total class grade is each homework assignment worth? I'll let you pause and think about how you might solve that. Okay, in my experience, students tend to overthink this one. So if the homework is worth 30% of your grade and there are 8 assignments, then each individual assignment, well, you take that 30%, you divide it by 8. Each individual assignment is worth 3.75% of the total grade. All right, another example. Suppose here are your 8 scores for the homework. 85%, 93%, 77%, 48%, 90%, 92%, 94%, 86%. So, okay, you know your grades on all of the homeworks. What is the average homework score? Well, to calculate averages, you just add up all of the scores and divide by the number of homeworks. So here, add up all the scores, divide by the total number of homeworks, and that tells you that your average grade is an 83% on the homeworks. So in certain problems you'll be asked to do, you might have to do these calculations first before then being able to take the weighted average. So this is just a regular old average, assuming that each of the homeworks are worth the same. And then in the so in that first example, we had to use the fact it's like, oh, you suppose you got a 82% on the homework, then that was the average score for the homework. So in a problem that comes up, you might not be given the average score. You might first be given, say, all the individual scores, and then you got to find the average score and then use that to calculate the weighted average, which is like your grade in the class. Okay. Last example is calculating your current grade in the course. So you haven't, up until the very end, you haven't completed the whole course, but you want to know sort of what your current grade is. Like, oh, am I currently getting an A, a B, a C? What's going on? And again, if you're a teacher, this is something you're going to be asked to do. I get asked to do this for all the student athletes periodically throughout the term. We say, all right, we're 5 weeks into the term. What's the student's current grade in the class? So let's do that kind of calculation, but where we're assuming you've done everything except the final project. I'm going to say, all right, what's the current grade? Well, the key is to realize that, okay, right now you've completed how much of the course? You've completed 80% of the course. And so now when you calculate your current grade, you're saying, all right, you still are saying, okay, I got 90% out of the 10%, 80% of this 10%. Ah, whoops, these numbers are wrong. Dang it. Okay, I'm actually going to, this is not the first time I've tried to record this video. So I'm gonna stop sharing and you're gonna get the experience that my students often get when they are in my class, which is, oh, I found a mistake on my slides and I just change it quickly. Okay, let's go back to the slideshow. I'll share again. Okay, back to reality. So you're getting 90% on this 50%, 15%, you're getting 80% of this 15%, 82% of this 30%, and 71% of this 20%. And so you're going to want to do all those calculations and add them all up. And then the key is to realize this is only 80% of the grade. So you got to divide it by 0.8. Because, so we've taken this 90% of 15%, 80% of 15% plus 82 times 0.3 plus 71 times 0.2. And the key is to realize that the whole is not 100%. The whole is only 80%. And so this is the part, this is the whole is 80% or 0.8. So this is the calculation you got to do to find your current grade. This is how much of the current 80% you've got, which would be 82% if I calculated that correctly. Although now I'm worried. So let's, all right, let's be thorough and see if I have another typo to correct. So 0.90 plus times 0.15 plus, you do this too, for those of you all watching from home. I suppose it's good to, I probably shouldn't rob you of the notion that I make mistakes. Definitely happens. 0.71 times 0.2. All right, that answer divided by 0.80. I got something different. I got 0.8. I got not this. I got 80.4%. Sorry, team. But all right. I I think you can handle it. I think that's the end. So let's see. Yeah. All right. Thanks for listening. Thanks for your patience with the errors on the slides. I will correct those when I post the slides to the assignment. All right. Thanks so much.